All right, it's 1 o'clock local time here, so why don't we get started? Hello and welcome to day one of IETF 116 here in Yokohama, Japan. My name is Sanjay Mishra, and I'm joined here by my co-chair, Kevin Ma. Welcome, everyone, and welcome to Yokohama. And finally, it stopped raining after 3 days, so that's a welcome change here. Today is Monday, March 27th, 1 p.m. local time. And so I greatly appreciate everyone's participation here, as some of you that are remote have either very early in the morning or very early in the morning. So greatly appreciate it. Thanks, everybody. We've got a packed agenda, so I'm going to keep moving forward. Let's see if I can do a next slide here. Okay, let's see here. Perfect. All right, so note well, and I really mean it, note it well. Everything is out here, so I don't want to read all the details there, but just be aware of the IETF policies on your contribution. All right, so next slide. A few tips. Most of you are fairly familiar with it. For in-person, make sure to sign into the session using the Meet Echo client, the light client, and also use the Meet Echo to join the mic queue, and keep the audio and video off if not using the on-site version. For remote participants, make sure your audio and video are off unless you are chairing or presenting during a session. Also, use of headset is strongly recommended. Some tips there. Moving to the next slide. These are some of the resources. Most of you are probably pretty familiar with those. Agenda and meeting preparations, and if there are any issues, technical support, etc. And with that, let me kind of walk you through the agenda. We really have, so the agenda is packed for 2 hours, and largely the discussion is going to be in two sets. One is we've got a lot of working group documents. There are 3 of them that we're going to be talking through the session here today. And then the second part is there are several new submissions. So we will be covering a set of 3 new submissions, and Glenn will also give an overview of those 3 before we go into each of the individual documents. So Glenn will walk through what the overall objective is and what they are, and then individual contributors, Will and Alfonso and Ben, will talk through specific items. And on the working group documents, obviously, so the one we want to talk about is the delegated credentials, and Christoph will kick us off the conversation there. And then we've got the CDNI triggers. Hopefully Neer is on the bridge as well, so he'll talk through that. And then capacity advertisement extensions, Ben will cover those. So we have those 2 major groups of discussions, and then we also have open mic, and then we'll wrap up. So with that said, I think I'm going to pass it over to Kevin for the other parts of the agenda items that we want to cover today, starting with milestones.
Hi, everybody. Welcome back to IETF. It's good to see you. I wish I could be there in Yokohama. For those who remember IETF 94, Yokohama is where I first started chairing CDNI. So, but our list of milestones we've reduced down for this particular meeting, starting here going forward. We didn't want to keep all of the old milestones, but these are the open milestones that we have still today. The big one is footprints. The footprint type draft got submitted. It is currently in the RFC editor queue. I think it's pretty much done, just waiting to get processed. So congratulations there. Hopefully that will complete soon. We did send out the working group last call, which we'll discuss in the next slide, for the ACME delegation draft. That leaves us with the 3 other items currently in our milestones: the triggers, the subcerts delegation, and the capacity advertisement, which we will talk about today. But if there are no questions here, we can move to the next slide. All right. So we did get the working group last call out. Thank you to Frederick and everyone for the hard work. We've been working on this draft for many, many, many years. It's nice to see it finally get to the finish line. There's a couple days left in the last call. If you have any thoughts, questions, comments, please post it to the list. Otherwise, I think the draft is in pretty good shape. We've talked about it a lot. We've done a lot of iterations on it. And if there are no objections, we will move to submit it to the ISG shortly after IETF 116. So please go read it and send out any comments. Otherwise, I'm looking forward to moving that forward. Sanjay?
All right, so I think that covers the chair's slides. And let's go back for a second to the agenda, and we'll bring up the first item is Christoph's document. So let me see if I can bring up the next deck here.
Okay. Hello, can you hear me?
Yes, Christoph, yes.
Okay, so yeah, that's so the draft about delegated credentials. Certificate delegation using delegated credentials. And yeah, next slide. So the scope is about, the document defines two objects, one MI and one FCI object, which enables the HTTPS delegation using delegated credentials. So we have those two objects. So last meeting, there was a discussion on what the proposal is and how those two objects work. So I have some details about that in the next slide. And so the current draft, which I submitted like 2 or 3 weeks ago, so it reflects the current proposal. There were small updates regarding more typos and reformulations. So next slide. So we have those two objects which are defined in the draft. So one, which is the FCI delegated credentials, which allows the downstream CDN to announce the maximum number of delegated credentials it supports. So that could be typically the number of servers it has and where it can deploy those credentials. So the object is quite simple. As you see, it's mostly announcing this number of delegated credential that it supports. And then we have this MI object delegated credential where the upstream CDN can put the delegated credential, so it's an array, and push it to the downstream CDN. So if we go to the next slide. So there was a discussion really about how do we handle expiry and how do we cope with the renewal of the delegated credentials. So here now the idea is that the FCI object is not used to cope with expiry and renewal. It's really up to the upstream CDN to remember when the delegated credential it pushed to the downstream CDN expire, and it is up to the upstream CDN to push those new credentials to the downstream CDN when needed. And the FCI object is really just here to announce that the downstream CDN is capable of or handling a certain number of delegated credentials. So on the right here, you have a example workflow where you have in step 3, you have just the downstream CDN, which announces the number of delegated credentials supported. In step 4, the upstream CDN pushes the delegated credentials using the MI object. Then those credentials are used. And at some point, there are some delegated credentials that expire, and then the upstream CDN can push new delegated credentials to the downstream CDN. So yeah, that's basically the status. Now the discussion, I think, is what are the next steps for this draft? do we push it to a last call, working group last call? And I think maybe there is also some discussion needed on the mailing list to polish a bit all the writings and maybe make it more concise, as Kevin suggested.
Hi.
I think we have. Go ahead, Kevin.
All right, I'm at the head of the queue, so I'm going to go ahead and just add. Christoph, I don't know if you saw my email. I finally got around to reading the draft. I sent out a bunch of comments. Obviously, we should address those. Sanjay, could you go back one slide, please? One thing here is with respect to the metadata interface pushing, CDNI does not have a push metadata interface, right? We have a triggered pull. So I think from that perspective, we may want to just clean up that language with respect to CDNI, though we can obviously make that generic to handle. I know open caching may have a push-based interface that they're using, and that's fine. But I think we can clean that up. There are a bunch of nits that I passed along. But otherwise, I think the draft looks pretty good. After having the discussion last time about what that metadata object will do, I'm okay with that. I think we're a little, we probably have to do a couple revisions before we can get to a last call, but I don't see any major blockers from my personal opinion. Thanks.
Okay. Thanks.
So, Christoph, I just have a couple of clarifying questions. I mean, I'm going to go back to, let's see here. So I think I agree with Kevin. Overall, the draft is looking really good. Has improved quite a bit in terms of clarity also. So I like that. I'll send something on the mailing list with some nits outside of what Kevin has. But I think it's looking good. The clarifying question I have is that you talk about the maximum number of credentials supported. That's not any hard limit, right? On the DCDN side, it's not tied to the number of servers either, correct? Because you talk about that there's a allows the DCDN to announce the maximum number of delegated credentials supported. So is there any hard limit there?
What do you mean by hard limit? I mean, it's just announcing that, well, as a downstream CDN, if you give me like 10 delegated credentials, I can handle them. I know where to deploy them. That's the idea behind it.
Right, but so if the UCDN decides to give you 20 or more, so that's what I'm trying to say. That there's no limit on your side, right? It is what the UCDN tells you.
I guess the upstream CDN can do that, but the downstream CDN won't use them. That's my interpretation. Because they would just, I mean, it doesn't need more than 10 in this example, or 3.
Okay. All right, that's all I had. Thanks for clarifying.
Okay. So I guess then the next steps is you will send, anyone send comments on the mailing list. I will update the document and take into account all the comments that I see on the mailing list to polish the draft.
Yes, I encourage everyone to go out and read the draft. The updated draft is, as Sanjay mentioned, a lot better. And we'll keep revising it until we get to a point where we're ready to submit. But everyone else, please take a look and provide your comments and make sure that it covers everything that we want to get out of subcerts. Thanks, Christoph.
Thank you.
Thank you. All right. Next on the agenda is the triggers draft. So let me bring that up. Okay, Nir, take it away. Just make sure that you're not on mute, Nir.
Nir had technical difficulties last time too.
Yes. Nir, we're not able to hear you. Let's see. I'm going to chat with him, and see if there's anything we can do.
Do we want to let Ben go first while we?
Yeah,
try
I
and
think
figure out
so.
Nir?
Let's do this. Let's have Ben go, and then we'll have Nir. We'll come back to Nir. So 1 second, Ben, if I can.
Okay, I clicked the request slide share button, so I don't know if that popped up something on your end.
Okay. Go ahead. I think you should be able to share.
Yep. Okay. All right, that should hopefully have popped up for everyone.
Yep.
Okay. So this should be relatively brief. So I'm just going to cover a summary of what this draft is for and what it does very quickly, and then we're going to get into the revisions that were made in the latest version. So capacity extensions, the whole idea is to allow the downstream to communicate to the upstream how much traffic it can accept so that the upstream can make appropriate traffic delegation decisions. To facilitate this, we've created two different objects: capacity limits, which specifies both a hard and a soft cap for various types of limits based on what you can see on this slide here. The most common of which would likely be egress bits per second. And then to go along with that, we've also defined a telemetry object, which allows reference to an external telemetry source so that the upstream can get feedback on the downstream's view of the current delegated traffic. In addition to that external mechanism, there's also an in-band property in the capacity limits object called current, which allows specifying a point-in-time value along with the rest of the limit objects. So those together allow informed traffic delegation decisions. This is just a brief example of what that object looks like. It's relatively straightforward, and none of this has really changed since the previous draft. The only thing that we've done, based off the discussion on the mailing list, is remove this scope object that used to be present here. So right now, this can be associated with a footprint like any other capability. In the prior draft, we had an object called capacity limit scope, which allowed a more fine-grained scoping mechanism based off of a host name or a service ID or a property ID. The feedback on the mailing list was that this is perhaps not the appropriate place to do this. Could apply across other objects. So we decided to pull that out of the draft. People are already implementing this capacity limits object right now, and I don't think there's any reason to let this stand in the way of the draft. If we do develop some other more generic mechanism, it can always be applied to this object in the future like it's applied to anything else. So that being said, the new draft removes section 2213. We remove all references to the use of that scope property. And that's it. So I know, Kevin, you submitted some really detailed feedback this morning, and I haven't had a chance to review that yet. So I will definitely go through each of your points and consider those for the next revision of this draft. Yeah, Kevin.
Yeah, I'm sorry, I got to it late, and so the comments are there. Hopefully they all make sense. I think the draft it definitely looks better, but there's still some questions. But I think moving in the right direction, we can figure those out.
Yeah, and
Thanks.
I definitely appreciate your thorough and detailed feedback. So yeah, that's pretty much. So I'll do another revision of the draft. I encourage everyone, please take a look through it and add your own comments as well to the mailing list. And I'm hoping, with the next draft, we can proceed forward with this. So we have plenty of time to meet the milestone for it. And given that people are implementing this already, I don't think we should wait. So I'll get the feedback incorporated, get the new draft out, and or the new revision of the draft out. And I guess the next step is a working group last call, or what do we do after this?
Yeah, once we've got it to a point where we think it's ready, then we'll do a last call and we submit. But I think we probably need to do a couple revisions. I did have one question about there's a configuration property in there for the telemetry source objects that's still TBD. Is that something that you have an idea on that you're going to define, or is that something that we may need to pull out?
So the configuration right now is defined as a generic container object. So it can be used to reference any external service because everyone has their own telemetry sources. And we didn't want to bog down this draft with defining configuration for, all of the dozens of possible telemetry services that people are using. So instead, it's a generic property container that can hold whatever is necessary to, to communicate the things that are needed to talk to those services.
I guess my concern is that as an object that has no actual definition, I don't know how to deserialize it, right? I don't know how to actually process it. And from an interoperability standpoint, that's a problem. Is it something that you could make a generic string or that, and then the parsing is, up to whoever needs to know how to parse it. But from a basic JSON parsing perspective, I can do something with it.
I mean, could you elaborate on why you can't parse a generic JSON object?
Well, I guess I don't know how to validate it. I don't know what fields it should have, whether, and I guess you're saying I shouldn't care, but it feels a little funny to me.
Yeah, I can understand that perspective. I think though, if the alternative, like you're saying, is we define it. Oh, here's a property that's a string that can contain your service specific configuration. It's like, okay, you can validate that this is a string, but you're still not validating the configuration of that service. So in my view, I would see them as equivalent. From that perspective, the difference is that if it's a JSON object, you still get typed data for whatever that service specific configuration is, which you would lose with some, generic blob.
Okay. I'd be interested in how other people feel about it, or how we could actually perhaps improve the text around that to make it a little bit more understandable.
Yeah, and I think Chris Lemons just pointed out in the chat that if it is just a string, people will just put the JSON sub-object inside the string.
Okay.
Yeah, an 80% chance
So
of
Chris,
properly escaping all the quotes.
I'll take that as Chris is okay with a generic object.
But yeah, I'll definitely take a look at the language surrounding that. Perhaps I don't know if we should really include a usage example with a service that's not defined in the spec. So I don't know how we would do that, because it's a little tough to include a usage example for something that's not actually part of the draft.
Yes, the
I don't know how you
TBD
feel about
really
that.
gets me. I think
Oh,
we could
yeah.
probably
No, we'll
describe
definitely,
something.
anything that's TBD, we'll have to get real
Yeah.
language around it for sure. Yeah.
Okay, thanks.
All right.
Okay.
I don't see any other comments, so thank you, Ben.
Okay.
Okay, see if I can bring up the. Neil, are you back?
Yes, yeah.
I see you. All right, very good. So let me bring up the triggers draft, your presentation.
Yeah.
All right.
Hey. So for me, it's good morning. Hi, everybody.
Good morning.
I'll talk about the trigger interface, the second edition for the trigger interface, which Ori, Sanjay, and I are working on. This is just a quick recap. What is the what the trigger is used for? So we have the upstream CDN and the downstream CDN, and the triggers are basically the trigger interface brings a protocol for the upstream CDN to manage content or metadata within the downstream CDN. It's an entire protocol with different objects, and what we mainly changed is the trigger object. Okay, the protocol itself remained is in the original version of the trigger API. Let's proceed. Next slide, please. Thanks. So, on the left, you see the original, almost original. The original trigger structure was composed of a type property, for example, preposition, allow preposition of content or purge or invalidation. And then there were several properties that defines which targets to run on, for example, meta URLs or content URLs. And then we didn't have the trigger extension, and then we had the CDN path that was used to for loop detection in case of a hierarchical CDN structure. So basically, this entire structure was allowing to instruct allowing the upstream CDN to instruct the downstream CDN. For example, do a preposition of this content URL, and that's it. We did three main changes here in the right side with the trigger v2 object. First of all, we changed the type to action. It's just a name change, but we think it's a more proper naming for the field that says what the triggers actually do. And the more substantial change is adding the trigger specs list. So instead of having a list of properties that is not flexible, we had a list of generic objects with the trigger spec that's saying what are the targets that the trigger should run on. Next, we added the trigger extension, which is also a list of generic objects. This list actually says how to run. It gives a execution special instruction. For example, run the trigger on 3 a.m. And we kept the CDN path. Next. I'll leave in the end room for questions, and I prefer to go over the entire presentation because I want to cover it all. So the first change, as I said is changing the trigger type to the action. We have currently three different actions, and we can add in the future other actions. Next. Then we define the generic spec object. The generic spec object specifies the targets to run on. One advantage of adding such generic objects beyond the main advantage is that if we need a new type of object, we don't need to change and create a trigger v3 object. Okay, if we want to define, I don't know how. I have no real idea, but we kept on adding those properties of content matching or metadata matching, and every such addition should probably be creating a new trigger version. So the first advantage is that we would not need anymore to add new trigger versions. The second advantage is that we can actually control via capabilities. The downstream CDN can announce via the FCI, the capabilities protocol mechanism, which specs it supports and which it doesn't. Okay, as I said, this is a generic object. We already have several types defined. And one additional thing, if you remember in the twist slides above, we had a metadata URL property and a content URL property. And here we decouples the way we select the target to run on via URLs, via regexes, etc., and the subject we run on. The subject can be metadata or content or something else in the future. So basically, that was basically this decoupling allows us a matrix of trigger spec type and subject type. Okay, and it will allow the entire protocol to grow. So the structure of the spec of the trigger spec, it's first of all the spec subject, then the generic trigger spec type, and the spec value. Okay, so in this example, the spec subject is content, and the type is regex match. Okay, so the trigger would run on content that match the regex, and within that we see the different properties of the regex match object. Okay, now in the previous version that we discussed earlier, we had a question about it wasn't a generic trigger spec value, it was a generic trigger spec values. Okay, we allowed multiple values here in a list, and this made the thing a bit complex and without the real need. So we have a single value per object. If someone want to specify two triggers within the same two regexes within the same protocol, within the same trigger, you can just add two different specs in the list, in the high level list. So there's no need to have a list within a list. And next, please. Okay, another example is the URLs example. Here inherently we have the spec value is built of multiple URLs. Otherwise, it wouldn't have made it. It can be a list of hundreds of URLs, and it won't make sense to have per URL the entire object. It's the same for CCID. Next, please. So this is an example for the entire trigger object. So here we have an action which is preposition, and these are the specs that it runs on. It would run on those two metadata URL in the example ABC and example ABD. As well, it would run on the content which is specified by the regex below. Now, as an engineer, whenever I see such a list, I immediately ask, okay, what the order of the list may mean. And here we decided that the order is has no significance for now. It may have in the future some significance, like only do the content, preposition the content, only preposition the content only after the metadata, because this is the order of the specs. If we one day we want to allow such a semantic, we can just add an extension that say that and support and use the extension whenever we like. I think it would be cleaner, and we should leave the structure as is and without saying giving any importance to the order currently. We can get back to this point later on. Next, please. So, following the change in the trigger object, we also had to change the arrow object, then create a v2 to include the fields that currently in the trigger object, practically adding the extensions and spec list. As we have a new arrow object, we need a new status object, but that's it. And the spec list actually is reflected to the arrow object. Okay, so if we, okay, this is not the specs from the previous example, but in this arrow, it means that this specific spec has failed for some reason. There's the error code and the description. Okay, we need to work on this example, but never mind. What's important to say is that the specs listed in the arrow objects are only the spec that the arrow applies to. Okay, we may have multiple specs in the same object, in the same trigger object, and only we failed to preposition one of them. So we will list only this one. We will put only this one in the list. Next, please. Okay. What we also added the generic trigger, the generic extension object, which actually control how give final control over the trigger execution, and as well we can the advantages of having a generic object is that we can add more and more as we wish, and have a matching capability for each one of them that allows the downstream CDN to announce what extension it supports. So we already have two types defined in this RFC, which is the location policy and the time policy. We will look at an example of one of them soon in the next slide. One additional thing that the extensions mechanism allows us is to avoid future changes in the trigger structure. Okay, for example, what I already discussed, that if we want to say that the order of the specs have some something behind it, some meaning. We don't need to change the structure of the trigger. We can just define the new extension saying run 1 only after 0 or whatever the one needs it would define. Next, please. So the structure is of the generic extension object is first the type, then the value, and then 3 flags that are used for for the cases that different level of protocols are supported, mandatory to enforce, safe to distribute, and incomprehensible. It's quite similar to the metadata generic object in those manners, and the definition is of this flag is pretty much equivalent. Next, please. So this is an example. So for the location policy and extensions, for example, we would like to have a preposition of content, but here we deny it from the US. Okay. This is the location policy example. We also have a time policy that says exactly when to execute the trigger, and we can add whatever extension we want, would like to. And next. Okay, so this is the last slide. What's left to be done? This is quite a long draft. It is based on the original draft, on the original RFC, and we added a few chapters to it and changed a few other. So we need to have a clear mind, a sweep review of the entire draft, and then hopefully submit it to prior to IETF 117 and aim for working group less call in 117. That's it. Now. And so if there are any questions, we can get back to the slides. And
I had a couple of questions. Sanjay, could you go back to slide 8, please? With respect to the ordered list,
yeah.
I understand the question about ordering, and I'm okay with leaving it without an order. I was wondering, what about duplicates? What do you do if CIT metadata shows up twice or 3 times in this list?
Okay, so I haven't thought about it, and thinking out loud now, the list is additive, so it doesn't really make a significant difference. It doesn't block the execution in any way. If one day somebody would like to add some kind of the complexity of ordering or thing like that, they probably should be able to address this point and define a new error code for that or something like that.
Okay.
That's it.
I'll admit I have not had time to read through the draft in its entirety yet, so if it's in there, I apologize, but that's just something we should probably make clear.
Well, we haven't. I haven't thought about it till now.
Okay. Okay. The other question I had was on slide 11. With respect to the generic extension objects, so for metadata, we have an FCI object, which is for advertising what metadata extensions we support. Do we need a similar thing for what trigger extensions we support? Is that something that needs to be advertised?
Yeah, it's actually, this is the second bullet. This is what
Okay.
we actually do both for extensions and for specs. So we can
Okay.
add specs as we go. There is a point here that actually the flags, the different Boolean flag that mandatory to enforce and etc. May allow us to avoid that. Say, okay, just fail on those circumstances. But I think a cleaner solution would be having those capabilities.
Right. If you pass the incomprehensible flag and things, then they know what to do and how to handle it, but you still want to add an FCI object.
Yes.
Okay. And that's in the draft. Again, I
Yeah, I
apologize.
think what we need, following your question, I think that we should add an error code saying for not for the extensions, but for the specs. That if the absence CDN sends an unfamiliar spec to the downstream CDN, where with spec we didn't have this mechanism of mandatory influence source because it didn't make much sense. But I think we should define a new error code and fail the entire transaction.
Okay. And then to the last question about our next steps, I think I would like to read the draft myself. I would like for everyone else to read the draft as well. It's a big change, and we need to make sure that we get a sufficient number of eyes on it, and then we can figure out when we can get to a last call. But I think there's probably a couple of revisions that we need to go through, and I'd like to see some more discussion on the list.
Yeah, Kevin, I echo what you're saying. So I think the draft is fairly large, and just the nature of the change requires that many eyes look over it and probably do multiple reviews. And I think we need to make some progress between now and IETF 117, at least have a few reviews and few submissions sent, so that we are fairly comfortable that the changes are good and will stand, and that the intent of keeping the document flexible remains that way. And in order to do that, just have to make sure that we do multiple revisions and make sure that the flexibility we are adding is really making sense.
Yeah, I would actually love to get us to the point where we can do a last call before the next IETF, but that's all of us to go ahead and get out there and do the work. So
there's a lot of work there.
Agree. All right.
Thanks,
If no other questions, well, let's look at the next draft here. Thank you, Nir.
Thank you all.
All right, so we're
There was
gonna jump
one
into some
comment
of the
in the chat from Glenn. Are notifications of asynchronous completion of work part of the standard? For example, content preposition completion.
Again, I didn't hear the question.
In the chat, Glenn had a question. Are notifications of asynchronous completion of work part of the standard?
There is, I don't think there is a notification mechanism. There is a status object that can be pulled and checked periodically instead of having the notification the other way around. I believe it's sufficient. This is we haven't touched the original structure of the protocol itself. We just changed the objects. If somebody think it's if we can discuss it offline, and if we think it's needed, we can do the extra work on that. But it's open a window for a very large set of changes.
Yeah, we've been talking
Right.
a little bit about this within the SVTA. You know, I think there'll be something required to give an asynchronous notification that, you know, pre-position or cache purge is completed, which might take, you know, many minutes or whatever.
Right. The original design was to be purely restful, a purely restful interface, and you know, you get back an
You pull.
ID for a status object that you can pull.
Yeah.
I think it would be a big change. We could think about it, but you know, as Nir said, do we want to couple that with the current changes? We can discuss it if it's a critical feature.
And actually, this is another example where extensions can be used. Okay, so one they may define the extension of, okay, report the completion to this endpoint, the completion of the to this endpoint. We can define such an extension, and some CDN would support it, and some other would not. And this is a great example for how we can do that. How can we use the extension object?
Good point.
Okay. So with that said, Glenn, you might just stay on here because you are next to go here.
Yeah, hi, this will be very brief. I just wanted to kind of put the next couple of presentations in context for where we are with the SVTA configuration interface project. So go ahead, next slide. Yeah, so you know, when the SVTA started looking at how we configure the open caching systems, we started looking at general commercial CDNs and open caching systems together and realized it was the same set of problems pretty much. And we picked up on the metadata interface work done in CDNI. And I believe I have your starting year wrong here. I don't think you guys did start in 2006. 2011, is that correct, Kevin? Is that more accurate? Something like that. So yeah, the idea is do this work within the SVTA, but then go ahead and share it back into the IETF. And that's what we're starting to do now. So next slide. Yeah. So July 2021 is when we submitted our first draft here, which we did 2 revisions on that. And we let it die. We got really good feedback, a lot from Kevin. Thank you very much. That it was just a monster, way too much stuff in there. It was really a set of MI objects going beyond the relatively small set of MI objects that were originally done in RFC 8006. But we took that feedback to heart. We did publish shortly after there our first version of the SVTA configuration interface with a multiple part document that had all of these extensions in it. So the part 2 doc really was a mirror of that original IETF draft, and a simple configuration API, which is pretty much the metadata interface from RFC 8006 with a few additional get methods to get by an individual host, but also I think was pointed out earlier, a push extension was added for an upstream CDN to push metadata into a downstream CDN. Now, interestingly, the new capabilities here discussed for the triggers, you know, you could use a trigger, I suppose, to push metadata. So we may want to look down the road at synergizing that a little bit. Anyway, since we published that first version of the SVTA standard, people have actually been implementing this thing. And, you know, there's nothing like learning through doing, and we see people implement this. We've gotten lots of feedback, have done lots of revisions, added many more new metadata objects, and we're aiming towards a version 2 of the SVTA configuration standard to be published this summer. As we've broken things up into pieces, we do plan on moving much of this into the IETF. 3 pieces are going to go in today that you'll hear next, and then there'll be another round of metadata interface objects definitions for IETF117. Next slide. Oh, and I see in the chat here, Kevin can't remember. It was so long ago that CDNI was started. I think it was 2011. Yeah, so the 2.0 standard for the SVTA configuration interface We'll have this metadata model extension is now broken up into multiple subparts, like we talked about. The 3 in red are the 3 that the guys will talk about today, but there are a set of these. Now, since these were originally done in one doc, there are some cross references. We're trying to decouple them and have the dependencies be loose. And if there may be cases where the dependencies are only in an example, the cross references, and we'll try to clean some of that up and make sure we're properly referencing the other documents. As SVTA does more work and proposes more new metadata interface objects, our policy has been, if there's some other logical home for those documents, like logging is a good example, we're going to have a logging standard spec, and we'll define metadata interface objects over there. But if there is no other home for them, we'll put them here as part 2 subpart extensions, just to have these general categories of metadata interface extensions. We're going to continue to have our simple API. We've also added in a layer, if you're familiar with the MI host index, we've added a layer above the host index that provides for common metadata across groups of hosts, reusable metadata, that sort of a thing. We're going to have a new part that we're going to put in. We may be able to talk about this at the next IETF. Kevin had mentioned FCI metadata. Wonderful, but pretty simple. We are considering some extensions, a new FCI metadata extended that allows you to define not only which generic metadata objects you define, but what context you allow them in, and also possibly allowed values and allowed properties. So that's a work in progress. And then we're also starting to look at a set of APIs and interfaces that work with some popular DevOps tools like Terraform and allow you to decouple configuration publishing from deployment. Right now in our push interface that we added, that simple interface, pushing metadata from an upstream CDN to a downstream CDN, it sort of implies publishing it to them and, oh, by the way, go live with it. There's no way to sort of stage it or put it into a staging environment or incrementally deploy it, blue-green, nothing like that. So we want to start looking at getting into that world of things. Next slide. Yeah, and this is the final. Just this sort of puts all the parts of the SVTA configuration interface spec in context. Basically, the FCI advertisement, moving from downstream CDN to upstream CDN. We cover some of that in parts 2 and 5 of the spec. A content provider pushing metadata in. That is this simple interface part 3. And then off to the right here, these newer use cases that we're going to be looking at really for later this year and next year, around Terraform and generally supporting orchestration interfaces. So hopefully that sets the stage for the next 3 presentations you'll get. Thank you. That's it.
All right. Thank you, Glenn. I don't see anyone on the queue here, so we'll just move on to the next slide. Next set of slides, and I think that's Will. Let's see here. Cache control metadata, I think. Yes.
Sure.
All right,
All
well, let me take it to the next slide here, right?
Yeah, so Glenn set the stage for work that we've been doing in the SVTA to add additional MI generic metadata objects. And this particular draft is going to focus on configuration options for setting cache control between an upstream CDN or UCDN and a DCDN. And there were 5 components to the presentation today. An MI cache policy that allows you to configure the internal and external caching policy. An MI object that allows for a caching of negative responses. An additional MI object that will allow for a caching of stale objects within the downstream CDN. There's also a small addition to allow the cache key to be configured in the downstream CDN. And finally, an object that's mainly going to be used for testing, which is the ability to selectively bypass cache based on a configuration. So it kind of sets the stage. If you want to go down to the next slide. Yeah, so the first one here is MI cache policy. And as its name suggests, it's really about how can we configure the caching policy in a downstream CDN. And there's really two key attributes. There's the internal caching policy and the external caching policy. So how does the downstream CDN itself want to cache a particular object, and how does it want to pass the caching information to an external user? There are also attributes to allow you to force that cache policy if set to true. Otherwise, the cache policy set up by the origin will take hold. Next one down. So in addition to positive caching, we want to be able to deal with negative caching. As you can see here, the negative cache policy actually contains a cache policy subobject, just for consistency. And the negative cache policy allows the upstream to list out a set of error codes that the cache policy will then be applied to. So in the example here, we've listed out 404, 503, 504 as negative responses, and then the cache policy that would apply would be, in this toy example, internal cache policy of 5 seconds, and we want to force that setting. So overriding anything that may have come from an upstream origin. Next one down. Great. So MI stale content cache policy allows for the handling of various error conditions and allows the downstream CDN to serve stale content under these conditions. So you can set the stale while revalidating attribute, which instructs the downstream CDN to serve out potentially stale response while it's revalidating upstream to avoid latency during that refresh. You can also set the stale if error. So if there's an error, in this example, a 5xx style error, while trying to refresh a resource, the downstream CDN can go ahead and respond with the stale resource. And then finally, a failed refresh TTL setting that allows you to configure how, if we have one of these conditions, how long do you want to continue serving that stale response before retrying the refresh upstream? Next one down. So MI computed cache key. This is a generic metadata object that will allow us to handle more sophisticated or complex caching cases. And in this case, you're able to set up the computed cache key to be based on an expression. And as you can see in the note below, the expression is out of scope for this particular draft and will be handled as part of the CDNI metadata expression language targeted for IETF 117. Next one down. And finally, a fairly simple MI cache bypass policy object. And this is primarily used for testing. So if you want to bypass cached resources during testing, you can match on various conditions. And if those conditions are met, you can set the bypass cache attribute to true, indicating that the particular request will continue through the downstream CDN to the upstream. And one thing to note is any existing cache content will not be evicted as part of this test object. So I think that covers all of the material. And as we have some questions that came up previously, we can either handle those now or we can jump into questions from this session.
So I
Okay.
don't see anything on the queue yet. And I have to review the draft, I know, so I'm going to hold off my comments.
Okay, I know we got some feedback from Kevin earlier today. Not sure if he's going to
Yeah.
jump in here.
I just got around to reading it. I apologize for the late read, but I did send out a bunch of comments. I actually think the draft looks pretty good, all in all. There are a number of issues we probably need to address just from a structural point of view. But I think in general, the metadata itself seems useful. I assume it is useful, otherwise you wouldn't be proposing it. So I don't have any issues with the content itself, other than, there's some stuff with the actual writing we need to clean up, I think.
Yeah, no, I saw your feedback earlier today, and we'll get into addressing those.
Cool, thanks.
Thank you, Will.
All right.
All right, so let's see. Alfonso, I think you're next.
Thank you, Sanjay. Good day.
And yes, bringing up your deck. There you go.
Thank you. Okay, so you can go to the next one. Yeah, so we are going to review this second draft of the set of draft that we have submitted from the SVTA working group. These objects, to the next one, please, Sanjay. So this set of objects in this draft, yeah, please, exactly, thanks, Sanjay, includes set of objects that are related to how an upstream can control somehow the behavior at the edge of a downstream CDN. So there are objects that include functionality that is typically present in the CDN industry, whether depending on the service or from content providers, on how the relationship between the edge and the origin service can be controlled. So we include here functionalities regarding the generation of headers for cross-origin, for coarse responses, a possibility to manage or to configure how to do compression of objects in the edge, controlling the client connection between the player or whatever browser that is downloading an object and an edge, and some information about the traffic that is being delivered by one service that is configured in a downstream. So yeah, we will go through all of them. Please, next. So regarding for the course for cross-origin responses, we're proposing this object, MI cross-origin policy, that permits the upstream basically to trespass the responsibility of the generation of coarse responses to the end user that is accessing an object in the downstream CDN edge. So typically, as probably most of you know, when there are situations whether cross-origin policies are in place when accessing an object, the player, browser, or client that is trying to get to a content will send an origin header in the request, and that triggers the course policies, whether in the response, the inclusion or not inclusion of a specific set of headers will allow the browser to pass the object to the application, and lately to have access to the object or not. So in the course definition in the W3C defines basically two modes for course. One, it's the simple course, whether only the check of the origin header is in place. There is then another that, depending on the headers that you want to pass to the application, requires a pre-flight request from the client with an options request that is needed for the browser or client to verify what are the headers that it's going to receive when doing the actual get of the object. And so for that, we please go next, Sanjay, to an example. So for these two, we include these two different examples. The first one, just for the usage of matching the origin header in the edge. So with this allow origin property, the upstream can define a list of those origins that are authorized to access the content. So the downstream will try to match the origin header in the request with this list of allowed origins, and in case that it matches, then the downstream is able to generate the access control allow origin header in the response. And we include the property for including the wildcard in the header, because it's one of the possibilities for the access control origin to include a wildcard, or to reflect the same that comes in the origin header in the request. So with these two properties, an upstream can configure this simple course use case. And for the rest, when there is anything in the request that goes far from just the origin header, but you need in the responses other headers, you need to, the client will do a pre-flight with the options request. So with these other properties, the upstream can configure the downstream to generate synthetic responses for the options request. So the downstream will not go to the origin to validate this, but it has all the information needed to self-generate the response for the pre-flight request. Then with this, the downstream is not bothering the origin with this kind of pre-flight and is able to generate the response. Please next. Yeah. The second object is the MI allow compress. This object is defined with the idea that when a client is using accept encoding header in the request, saying that it's able to receive compressed objects with gzip of any other algorithm. In a typical use case, the downstream CDN should go to the origin, including the access encoding, and should receive a response with a vary header, and start storing the different objects in compressed way. So if you have one client requesting with gzip and another client with a different algorithm, the downstream should go twice to the origin. So to try to reduce this traffic from the downstream to the upstream origins, this object will permit the downstream to compress itself the objects depending on the access encoding in the client request. So only requesting to the origin once that object, typically in plain, and it will be the downstream in charge of doing the compression. So again, this helps to reduce the traffic and the effort in the upstream CDN origins, taking advantage of the computations properties in the edge servers. Please next. With this other object, my client connection control, it permits the upstream to define some configuration in the client server level. So it permits to configure currently this connection keep a lifetime in milliseconds. So the upstream could use the information it has regarding the service, the end-to-end service from the client, maybe a content provider player, and the video service. It has knowledge of what are the requirements regarding the timeouts and connection. So the upstream could provide this information to the downstream and configure somehow how these connections levels should apply. Instead of not using it, that will be the downstream CDN own restrictions or properties in use. So having this information, the upstream could have a better control on the connection of their, maybe if it's a content provider acting as an upstream, and knowing the service can control better how the client is going to behave. And that could be maybe useful for the downstream CDN, having proper information on how to control the specific client's request to the downstream. Yes, please, next. And this MI traffic type, and this object permits the upstream to give more information to the downstream of what kind of traffic is going to be delivered for a specific service. So this is very important information for downstream CDNs, because typically the way the clients or a service is delivered is different if you have a VOD traffic or a live or linear traffic on OTT. The way the clients behave, how they make the request, or what is the the time to live of the different objects is quite different for VOD or for live. Live has more temporary objects that typically are expires very soon, while VOD content, you typically want to have it in your cache for a very long time. The how to request the manifest or playlist objects is very different too between live VOD or object upload. So this information is crucial for the downstream CDN to be able to apply different logics to the streamers, knowing this information. In that way, the downstream CDN can be very more efficient on how is delivering the traffic and how the cache is managed. So it's quite important for downstream for having the best performance in the streamers or the servers or cache nodes to have this information. A part of the traffic type property that could be required in this object, we have included a hints property that is the value. It's up to the upstream to include the list of these properties. So the downstream could or not use this information, depending if there is any algorithm or any or something it can do for those hints. So it's a valuable information, but it's not necessarily conditioning how the downstream is going to manage. The hints are not mandatory, and it's more a free list of properties the upstream can include. So probably out of band operator of a downstream could use that information to apply specific policies in the downstream CDN. Please next. Yeah. So now for next steps, I hope that the people in the group can take a look to the draft and make as many comments so we can have this draft progressing. Well, after this review of people, we kindly ask for adoption of this draft as a working group document. Thank you. I don't know if there is any question. Okay.
No questions, but it's a good draft. You've covered a lot of material there. I'll post comments in the mailing list.
Thanks.
Yeah, I haven't had time to read through the draft completely either. So I will also be sending out comments soon. Thanks.
Perfect.
All right, so I don't see any other comments. Thank you, Alfonso. Thank you for the presentation.
You're welcome.
All right, so let's see here. Looks like, Ben, you're back again. am I displaying, or you want to control?
Yeah, that's it's a short deck. So
Okay.
we just go to the next slide, please. All right. So the intent with this draft is to allow transmission of secret sensitive data between the participants. So this serves as a prerequisite for a number of future drafts that will incorporate these objects. For example, for transmission of auth tokens, for transmission of encryption keys, within the context of the configuration and advertisement objects. So in building this, we wanted to have two major modes of operation. One is we wanted to allow a simple mechanism that allowed everything to happen in band without consideration for external services. So, we didn't want the parties to have to, outside of the existing interfaces, to exchange something before secrets could then be exchanged. So to do that, we have the first mechanism based off of X509 certificates. So using public-private key pairs, the certificate can be shared by one party that is then used to encrypt the values on the other side. In addition to that, because many organizations utilize existing services for accessing secrets, we have a reference mechanism that points to an external service. The current draft defines a configuration object for HashiCorp Vault key value store, but I think the intention is we'll expand that over time to incorporate other services, or also include something like a generic mechanism like the telemetry object in the capacity draft. Next slide, please. So the first part of this is an object called secret store, and this is the configuration that says how to utilize the secret values that are embedded in other objects. So the supported modes are the embedded model, where we have encrypted values in CMS format. So that's a RFC that's been around for a very long time, originally targeted for exchange of encrypted email, which we're reutilizing here because it's fairly straightforward. We also support a clear text format for testing purposes. So that allows you to just utilize the secret value object anywhere where it's needed in other objects, but just include the value as a plain text string. And then the third example here is a reference to an external HashiCorp Vault instance, where we have to specify the endpoint. Next slide, please. Secret value is how you actually reference the secrets inside of the places where those references need to happen. So this could be inside of a property, for example, in an MI object that contains a header auth token. It could be inside of an MI object that contains an encryption key for an encrypted value in a log file. So in the case of an external reference, we specify a path. So you utilize that in conjunction with the store configuration to generate your ultimate URL that you're going to use to access the secret on that service. In the case of embedded secrets, where it's a CMS message, it's literally the base64 encoded CMS message as a string value. Next slide, please. Secret certificate is how the X509 certs are communicated in band. So it's really straightforward. It's just a PEM format stripped of the header and footer, embedded directly in a string value in the secret certificate object. So the draft doesn't tell you right now how to handle your PKI. So that's, I think, out of scope for this draft. But this could be handled, for instance, in a testing environment with self-signed certificates, in a production environment via private PKI infrastructure with a private CA, or it could even be a third-party CA that's accepted by both participants that signs the certificates. Next slide. And then to facilitate doing this in a bidirectional manner so that secrets can be shared from both sides, there are capability objects that wrap the MI objects. So the same functionality can be done from the downstream side via the FCI interface. And that's pretty much the whole thing. It's pretty straightforward. Two simple mechanisms for exchange of secrets. It might be a little hard to envision why we need this without seeing some clear examples of usage in the context of these new MI objects. But those are coming, and this is just kind of that's a dependency of this is a dependency of those future drafts. Any questions? Yes, Kevin.
So you're going to have this draft be independent just to define these objects, and then there will be future drafts that use these objects for whatever purposes, if I understand correctly.
Yes.
These objects by themselves seem okay to me. There's a fine line here between specifying data or configuration and actually creating a security protocol or something that falls well out of our charter scope and possibly in a different directorate like sector. And so I get nervous when I hear that we're going to build something on top of this, and maybe I just have to wait and see what that is. But I just want to voice that particular concern with respect to how deep we go into like specifying a URL that points to HashiCorp. Okay, fine. That's probably, perfectly okay. But once we get into other things where we're specifying keys, and then we start specifying how to get keys, and we start specifying how to use keys, it gets a little dicier.
Yeah, I understand that. And that's why the messages themselves are based off an existing RFC that's battle tested for, 15 years or something now. We're not doing anything new here. We're just reutilizing an existing facility for exchanging encrypted messages. So we're not going off and finding our own thing.
Right. And so the what's presented here seems okay to me. It just I get a little nervous on where we might be going with it. But I'm just putting that out there.
I mean, maybe we can include some usage examples that are like supplementary material and won't necessarily go in this draft. They'll just be there for now until the future drafts are introduced that utilize these objects. So maybe, it could provide some more context for why this is necessary.
Yeah, I think use cases might help, especially when we go and try and get a sector pre-review and they start wondering why we're doing this, right?
Mm-hmm. Yeah, we can definitely do that. I don't know. Would you want to? I don't know how would we submit that? Could we just append it to the draft for now and then we tear it out later, or should it be a separate document, or how would you want to do that?
I haven't read the draft fully yet. You could put it in appendix, which would be fine. It's not binding. Okay. It's just an appendix for this draft. If you don't want to write a separate draft, or you could submit a separate draft depending on how big it is and how many use cases you have.
Okay,
we could figure that out.
Okay, sounds good.
Chris is in the queue.
Yeah, so like one of the things this is useful for is the when you talk about delegating with URI signing tokens, you have to indicate to the DCDN, and there are some of those exchanges that involve moving around keys that are actually sensitive. The URI signing token as it stands, the current one, doesn't actually need that, and that's a good thing. But there are some situations where you would want to have one of those moved around, and this is super useful for that if we have this. That said, I think for interoperability, you're going to struggle with interoperability if you completely leave the PKI out in the unspecified zone, because anybody who wants to use this has to negotiate the PKI. Like you can't sign one, you can't encrypt one of these things to the DCDN's public key without getting that key, right? So I think we may find that for interoperability reasons, it's just not useful without a way to get the key that you need to encrypt it to. And as soon as you start doing that, all of those questions about are you building a security protocol become very interesting, because I think that you are. And I think that we might be building a security protocol whether we want to or not. And I don't know that it's necessarily going to be a good thing if we hand wave the important parts to avoid doing them properly. If any of that makes sense.
I'm not sure I agree entirely with that line of reasoning. We also don't specify how the parties authenticate to each other to access these objects in the first place. And that's a similar issue, is how do you establish trust between the participants? That's currently also out of band. So if we're going to answer this question of how do you get your counterparty's certificate in a way that you can trust, that's similar to the question of how do I authenticate someone to access these objects in the first place. But you know, maybe we could be solving that question as well.
I was going to say, I think those might be the same question, right? So like if you've established the trust relationship, then you may be able to just specify the transport of these keys so that implementations can be interoperable, assuming that they have the trust relationship. But yeah.
And since this mechanism is based off, for the embedded model, is based off X509 certificates, it is possible to reutilize the existing X509 certificates that are used in the TLS transport for the, you know, whatever interface you're using to transport these objects. But since we're not specifying that, it's kind of you know, this draft is not the place to do that.
Okay, I might could buy that.
But yeah, I agree. It's kind of a chicken and egg kind of thing. Any more
I think
questions?
the point is there, though. There is something on the horizon that we all like feel. And so if we can figure out a way to clarify that so that everyone feels better about it, even though the contents of this draft are okay, that would be helpful. So.
Okay. Well,
Yeah,
I mean,
and
maybe
I
everyone
think
can read through it and we can discuss it further on the mailing list.
Yeah, I haven't had a chance to read through it. I will and provide comments, and we can take it up, especially if there are some good use cases that we can lay out and are clear. That would definitely help.
I agree. I think the use cases would really kind of explain motivation and, you know, why we're talking about security in CDNI. So I think the use cases will help.
Okay. Well, that's it for me.
All right. Very good. Thank you. Let's see. So I think from the agenda, we have covered the key topics that we had in terms of the drafts. And we do have an open mic. And I know Alan wanted to cover some of the work that he's working on. He just didn't meet the timelines to get his draft in. And I do see that Alan, you did submit your draft this morning, and obviously I've not had a chance to take a look at it. But certainly, if you so wish to want to talk anything about your draft, certainly you can use the time here in the open mic.
Thanks, Sanjay. Yeah, so actually, I shared the deck. Maybe if you have it, maybe you can share it.
So if you send
I can
something,
try.
it may be
share
easier
my-
for you to just bring them up, because I haven't seen that draft.
Sure. Okay. Do you see that properly?
Yes.
Right. So the topic is support for named footprints. It's a topic of discussion that came up in several discussions and work groups we have at Open Caching working group at SVTA. So kind of this kind of mini project that got born out of that in recent months. So what the motivation, I think, to begin with, to summarize a high level, right, is that we see that multiple use cases have emerged that kind of require more advanced footprint capabilities that I think have been explored in Open Caching and or CDNI until now. And just some example of kind of business use cases. This is where we're seeking to have multiple distinct access networks to be managed under common DCDN management, while still distinguishing and differentiating between different access networks. Differentiated CDN layers. So there's a whole topic of kind of last mile / edge cache layers and how you manage them, and within DCDN with potentially different functionality and coverage. It can also be dynamic, as well as various geography-related requirements that exist in CDN. For example, like topics like GDPR and so on. So all of them kind of rely on some form of footprint to be used. And kind of what we have in kind of CDNI today, we could kind of find a bit lacking. Because sort of right now, footprints really are kind of, when we say FCI, we really mean footprints and capabilities, but that's really capabilities, and footprints kind of an afterthought. What we need is ability to have footprints to be used in metadata, both inside FCI as done today in capabilities, but also outside of it in configuration interface / metadata, in new and in new other kind of efforts that we're starting, like and we'll be bringing forward here, I'm sure, in the future, like cache management, logging, and so on, to be able to refer to these capabilities in a footprint context in a consistent manner. So have a way that to have scope of that footprint to be global, as opposed to right now it lives within individual capability, and cannot be used as, kind of consistently across different places and in the interfaces. Other things that we found lacking is the thing that we require more complex footprint definition logic, because kind of it's often we found that kind of you have to say complex things like all users in a particular country, but exclude this and that, but don't exclude this, kind of, so various kind of complex Boolean logic. As well as dynamically changing footprints that are kind of change often. So especially in the context of, let's say, last mile or edge caching, where kind of coverage may change quite dynamically. So we need good support for that. So all of that kind of bringing us forward to kind of the following draft. And again, just submitted this morning. So that's initial submission. But the changes that we're proposing are kind of at high level are as follows. So we want to extend FCI to actually advertise footprints separately from capabilities, in a way that those footprints, to make them accessible, kind of both as one common advertising. So you can actually get all those footprints in one API call and have it, but also have individual footprints to be accessible as well. So they can be referred to kind of as objects. And this advertising, we want to be hierarchical, because clearly there is a case for kind of at least a couple of layers of embedded footprints within one another. Adding namespace support, and I'll expand on that if we have time today. And supporting caching, really, because that's a way to support dynamic advertising. So you can publish a footprint definition that's valid for some amount of time, and in combination with individual footprint advertising, UCDN can poll, query those footprints it cares about more often than, for example, others. So if you have more dynamic footprint, that's a definition, and you want to query that because you use it, you can query that every 900 seconds, but query others once a day or even more as needed. So provide this kind of footprint by footprint caching logic is what we're looking to do. So as a result, I think the overall kind of CDNI operation mode kind of changes that from, I think now, kind of, I think what's implied, maybe I haven't seen like actually explicit referral to that, but I think that the intention is that capabilities can be refreshed periodically, but not too often. And I think with introducing footprint advertising that may change more dynamically, we kind of want to have as part of the bootstrap process to have a separate retrieval of footprints that are named, the advertising, and I'll show the details how it's done, and then allow periodic refreshment of those cache copies of footprint advertising as needed, including individual ones. To support those things, and other goals motivations I mentioned before, we're introducing two new types. One is a named footprint, so that's ability to refer to footprint that have been advertised kind of into this new process by providing a URI to that footprint definition. And the second type is actually tapping the CDNI metadata expression language in the MEL to define a footprint in a complex way, yet keeping that quite concise. And that potentially may supersede or complement the other work has been done around footprint union. So, because I think the MEL kind of goes well, above and beyond that by providing Boolean and or in combination and expressions, kind of powerful expression language. So that may be something that can supersede the footprint union draft that's making its way through the group. And last change is another implementation detail that came up is that we see that some of the complex footprint types actually are ambiguously resolved. So when you say good things like country, so it's a good thing to say, well, here is all endpoints that come from US, it's a match, but what is US can be subjective because in reality implementations use different GeoIP databases. And we found that in some cases they may not match, which may resolve into kind of delegation issues, mismatch of basically if UCDN, DCDN do not agree what US is, or even in some cases, which IP address belongs to which ASN. So they need to have some consistency. So we want to introduce some of that to the extent we can, and there's certainly limitations there. But kind of...
Hey, Alan, hold on a second. I think I see Ben on the queue. I'm not sure if Ben has some comments here, or Ben, you want to wait until the end?
No, I have a separate topic.
Okay. All right. Sorry. Go ahead, Alan.
Right. Yeah, just to leave the time. So the proposal is to allow within FCI to kind of have resources that you can actually query advertising of footprints, but also individual footprints and namespaces. And on the right, you see an example of how that advertising could look like. You see the new type of footprint called name footprint, which provides a name, the URI, the kind of caching information expiration, and the definition. Kind kind of and accordingly, with the advertising including caching information, basically, here's my definition of footprint. It's good for another 24 hours or 900 seconds, what have you. Then, so each definition comes with its own expiration attribute, allowing for differentiated querying, right? So UCDN bootstraps this by retrieving initial advertising, getting all the footprints in, and then refreshing them as they expire. And also, it may skip the footprints it doesn't care about. So if there is a footprint it's not using for its own kind of request handling, it may actually not query this too often, right? And certainly, but even it does, so it queries that individual footprint separately from others that have longer TTL. Caching, introducing hierarchy, right? And just to walk you through an example, right? So on the right, imagine that you have a footprint that, as I mentioned, let's say you have a common DCDN that actually operates to distinct geographies. You may have a footprint for US and Brazil. And for US, it may have a separate sub-footprint within it, which is we call US Edge, that is lives within same ASN, but has like a subset, maybe a list of IP addresses or CIDRs, things like that. And the purpose to define an actual explicit hierarchy as opposed to, let's say, implicit, for example, as you see in a routing table, is that footprint definitions combine different types. So it's not necessarily clear without actually stating what hierarchy is, which footprint is more precise. So hierarchy is there to define basically the descendancy. And the assumption is that the parent footprint includes all children footprints within it. And the matching is unambiguous. So within same tree, the IP will match kind of will match Brazil, but will not match US. So that's kind of up to DCDN to define in an unambiguous way when it does and publishes this advertising. So namespaces. So namespaces will show that we have multiple types of advertising on the right. So, and the motivation here is that the breakdown may be different depending on type of traffic, for example. And type of traffic can be many things. It can be the kind of individual host name. It can be kind of combination of them. It can be a prefix. So rather than tying that kind of into the advertising, we provide a namespace which can be then referenced from the metadata objects, like, for this traffic, I'm using this namespace. An example of motivation for that, for example, that you may have situation where DCDN handles live traffic, for example, always centrally. Right, it doesn't use a sub layer, so there's no separate namespace. But for VOD traffic, for example, it does, and that's a way for it to kind of provide differentiated namespace advertising for different kind of traffic types and capabilities it has. And I think that's the last slide. Just an example of what we can achieve with the MEL expression. I'm kind of quite excited about this. So I think that you've seen that kind of those, as we build kind of complex footprint definitions, that can be pretty hairy, right? And actually quite lengthy to build it using JSON. So using the expression language, you can do, first of all, kind of concise definition that can meet various kind of types of logic, like, hey, this is this country, but exclude those CIDRs, and or kind of match, exclude IPv4, IPv6, exclude kind of include a country but subdivision code, and so on and so forth. So kind of very powerful capability to do that. And we're building on the MEL draft that kind of our colleagues submitted, and but to support the footprint logic, we need to add several variables that kind of describe not a request and response, what was done until now, but actual endpoint, which is the endpoint that is initiating the request. And you see on the left here the five variables we're proposing to add: ASN, IPv4, IPv6, country, and subdivision. I would just kind of one more thing I want to add, and that's a topic of discussion, and that was something we had at the previous IETF, is about kind of, do we, when we define footprints and kind of build this new footprint related capabilities, do we maintain footprints as they have been defined in CDNI until now, which is mostly footprint is a definition of collection of endpoints that a CDN is willing and able to cover, right? Coverage of endpoints, or we actually extend this to mean also sets of traffic within the footprint. So do we actually build the kind of various ways that may exist that you can build actually traffic definitions into this, or we build it into separate object and bind and link them together. And this kind of links to what Ben mentioned around capacity, that's I think one place that came up, but there are others as well. So kind of, do we scope capabilities in object by footprints that are coverage, or we extend this to mean also traffic subsets in it as well? And that's
Hi, Alan. I think there's a lot of interesting stuff here. I'm looking forward to reading the draft. I think there are some questions, as you've mentioned. You know, it is a departure from what we have traditionally held with respect to what footprints are, what the footprint interface is, what the footprints mean. And I think it's a healthy discussion for us to have. But I'd like to read the draft, and I encourage everyone else to read the draft too once it's available, so that we can go ahead and have that discussion. We can choose to change the definition, but it's not something we should necessarily take lightly.
Agreed.
Nir, did you have a comment on Alan's proposal?
Yes. A few things I would like to happy to better understand. First, regarding the hierarchy. Okay, I didn't understand where all the structure is going to be defined. Is it part of going to appear on the FCI or not? And when we define hierarchy, is there a way to say, okay, this is the US, and now I separate it into separate 3 areas and the rest, or something like that? Is there any, what's going to be the syntax of that? This is the first question.
I guess, Nir, I'd like to give Ben some time to ask his open mic question. I think if we're getting into the details of Alan's proposal, I'd rather read the draft and take that to the list.
So I'll give 3 more points. Just a point. Just first of all, take also into consideration all the draft that referring to the footprint. Second, maybe we need a new footprint type, which is a footprint, a named footprint. If we are going to, if we want to start and make some mix and match. And last, regarding the endpoint as considering endpoint in defining footprint, one may actually define a capability as a footprint element, as a footprint object. Meaning, if we use this capability, this capability is used, you can also use the other capability or something like that. So it may, or if we point at capacity, if you use this capability, this capacity will hold, something like that. So in this context, it may be also good to think about it. And
items 1 and 3 actually are in the draft. Alto is not something that I think is clear to me how it's be matched. So happy to discuss this further. And the fourth comment also kind of happy to kind of you expand on that. But yes, let's
okay, let's take it off.
To Ben.
Thank you.
All right. I just wanted to quickly ask about milestones, because at the beginning of the meeting on your deck, Sanjay, you said that we had to recharter. I think it was October or August, one of the two. So given that we're submitting all of these new drafts and we have a lot of activity now surrounding them, what are the steps forward to incorporate those or incorporate the future new work as milestones and continue the working group past the recharter deadline?
So we can change the recharter date. That is there based off of the milestones that we have. If we choose to adopt additional drafts and they fit within our existing charter, we can continue to push that out. We will look at where we are. We have missed some of our milestones, so we will be updating our milestones after this meeting.
Okay.
But I wouldn't concern ourselves so much with that from a protocol perspective, we can address. With respect to when we adopt new drafts, that's more a question of the maturity of the drafts. And as long as they fit within our chartered scope, I do have some thoughts on whether this last one that Alan brought up fits within our charter scope, but we'll deal with that when it comes. We can always recharter. Rechartering is not necessarily an high onus, as long as
so it's not like a hard deadline, like we have to do this by X date or we're done. Okay.
No. Yep.
All right. Well, that was my question.
Cool. Glenn.
Yeah, I have a handy example I can show. Just take a second to show a good example of MI secret value, since it was sort of just amorphous. So I'll just share if I can. Is that going to work if I share my screen here? How does that work?
Yeah, it's coming up.
I can give it to you.
Okay, good. Great. Yes, I do. Okay, can you see this?
Yes, you have 1 minute.
Yeah, that's all I need. Yeah, so this is an example of MI source metadata extended, but it's really similar to the MI source metadata from RFC 8006. And here we're defining a source that needs authentication, and we've
I don't see it on the screen here. Kevin, do you see the draft?
No, I don't see it.
Me neither.
Oh.
Yeah.
Oh, I got to choose. Oh, hold on a second here. I see. Yeah, I see. Never mind. This should see it now. Now you see it?
All right. Yep.
Yes.
Yeah. So let's take a second. So source metadata, we're defining a source that needs to be authenticated with a header auth. In this case, the header passed from the downstream CDN to the upstream CDN. The header name is xorigin auth. And here, instead of putting the secret header value inline, we use the MI secret value here to reference the header value in an external key store. So this is just a type of example of why we needed this sort of structure. That's it.
Okay, thank you. Sanjay, we have 2 minutes left. You want to wrap it up?
Yeah, so I think I'll give you the minute. I'll take the first minute. So I think there's a lot of new drafts. So for the new drafts, what I would say is that really folks that are here on this conference, please review the draft and provide your input into the mailing list, because that's important for us to sort of gauge where the interest is and who is implementing it, etc. So I think it's very important that folks review it and provide their drafts. That will really help us to sort of take the next steps and adapt those drafts into the working group. That's one thing. And then I would also say that footprint that Alan has proposed, we need to take a look at it really carefully. It may make sense, but it's something that we need to take a look at it. And then lastly, I would say that RFC 8007 BIS that presented, again, that needs a lot of review. So I'm hoping that between now and before we meet at IETF 117, we've got some good input. Kevin?
I will second everything that Sanjay just said. I'd like to thank folks for bringing the new drafts. Glenn, I'll say the work is interesting, and I'm happy to see it. And I think we here in the CDNI working group are happy to take it on. But again, everyone, please go and read the drafts. Please provide your comments, and we will take it from there. Otherwise, thank you, everyone. Sanjay, thank you. I hope you have a safe trip.
Yes, thank you.
And we will see everyone at IETF 117.
Yes, and thanks everybody. I know it's late for some people and very early in the morning for some folks, so really appreciate all your patience. Thank you.
Thank you.
Thank you.